Hello students, this is Mrs. Youd, and today I'm going to teach my Algebra 1 students Chapter 4, Lesson 2, which is about writing equations in point-slope form. Please have out your journals, turn to page 103. The point-slope form of a line is y minus y1 equals m parentheses x minus x1. Just like in the y equals mx plus b, m is the slope. So the variable m, you would be inserting the slope in that spot. And the y1 and x1 is any point on the line. They have a nice visualization here that explains it. Please pause the video and read through what this says for just a moment. Okay, we're going to take some notes down here. I want to show you two examples, one where you're going to be given a slope and a point of the line, and the other one where you are given just 2 points on the line. So for example, if you are given that the slope is -1/8 and the point that is on the line is 3, -5, what you would do is you would take your formula, y minus y1 equals m parentheses x minus x1, and you're going to substitute in what you know. So we know the slope is -1/8, so the m is going to become -1/8. We know that the point is -5, so the x number is 3, so that's going to go here with the x, and the y number is -5, so that's going to go here with the y. So now when I rewrite it, it's going to be y minus a -5. Notice it's a double negative because the formula itself already has a negative, and then the point also has a negative, equals, and then we have -1/8, parentheses, x minus 3. That even though the 3 is positive here, it looks like it's -3 in the equation because the equation itself has a negative. So to simplify this, we're just going to change it to y plus 5, and then the remaining stays the same. And if you wanted to solve for y on this problem, you could, and you would change it into slope-intercept form instead. But as it is, this is point slope. Okay, so now we're going to move on to this equation here, where we have 2 points that we are given. So step 1 is to find the slope. So that's what we're going to do first. So our m equals, we want to write the skeleton of the formula down. Remember, my y numbers go on top, so I'm going to put 2 and -2 on top. My x numbers go on the bottom, so 1 and 3. So this is 2 plus 2 on the top, which is 4, and 1 minus 3 on the bottom, which is -2, and we always simplify if we can. So this turns out to be -2 for my slope. Step 2 is to plug the slope that we just found up here and either point. So you can choose if you want to use 1, 2, or 3, -2. So you can choose which point into the point slope formula and then solve for y. A lot of students think, wait a second, it doesn't really matter which point you choose, and I'm telling you, no, it doesn't. I'm going to go ahead and show it to you both ways. So let's write our formula down. It's y minus y1 equals m x minus x1. So I'm going to plug in my slope, which we got as -2. And I'm going to go ahead and do the 1, 2 point here, and then I'm going to do the 3, -2 point here. So if I plug in 1, 2, my x is 1, my y is 2. Okay, so now it's going to become y minus 2 equals -2 x minus 1. So now I need to solve for y. So if I'm going to solve for y, we need to first distribute the -2 into the parentheses. So that's going to become y minus 2 equals -2x plus 2. Now we need to finish solving for y by adding 2 to both sides. So I'm going to add 2 here and here, and I end up getting y is equal to -2x plus 4. And so this is my answer. So now let's plug in the other equation. So we have y minus y1 equals m x minus x1. And I'm going to plug in my slope is the same that we found, -2. This time I'm using 3, -2. So 3 is my x, -2 is my y. So now I'm going to simplify this. We have y minus a negative 2 equals negative 2, and then x minus 3. Need to distribute because I need to solve for y. So I'm going to change this to y plus 2 equals negative 2x plus 6. Now I subtract 2 on both sides, and I get y is equal to negative 2x plus 4. You'll notice that in both cases, I got the exact same answer, negative 2x plus 4 and negative 2x plus 4. And so what I did was I changed my point slope form into slope intercept form. And a lot of people like graphing from slope intercept form more than point slope form. So that makes it a little bit easier for graphing, but you don't have to. You could still graph from point slope form if you want to. On the next page, it says in exercises 1 through 6, write an equation in point slope form of the line that passes through the given point and has the given slope. So let's go ahead and write down the point slope form again. It's y minus y1 equals m parentheses x minus x1. So what you're going to be doing is plugging in numbers for the y1 and the x1. That's going to be your point. And then you're also going to be plugging in the slope for the m. So on number 1, we have this is going to be our x1, this will be our y1. So I'm just going to go ahead and plug it in. Y minus my y1 is 1 equals my m is negative 3, and then we have x minus my x1 is negative 2. So now we always want to simplify if we can. Y minus 1 equals negative 3, and then x plus 2. They're not asking us to change it into slope-intercept, so I can just leave it as that as my answer. Most of the rest of these problems are the same. I am going to do numbers 4 and 5 because they have zeros in them. So on number 4, this is my x1, this is my y1, and then my slope is here. So it's y minus y1 is 0 equals my m, and then x minus x1 is 5. Okay, now whenever you have a 0 here, you can simplify it by taking that 0 out. So y equals 4/3, and then leave in parentheses x minus 5 if you're asked to leave it in point slope form. Otherwise, if it's slope intercept, you would of course distribute in the 4/3. Okay, number 5, this is my x1, this is my y1, and this is my m. So y minus my y1 is 4 equals m, x minus x1. So now I can simplify because I have a 0 here. So this is y minus 4 equals 7, and then x, I guess you could put in parentheses, but you don't really even need that. But I don't need to put my 0 here, so I'm just going to change it to 7x. And then this is my simplified version of the point slope form for number 5. I would like for you to do numbers 2, 3, and 6 on your own. Okay, here are the answers that I got. Pause the video and check your work. If you got anything incorrect, see if you can find your mistake. In exercises 7 through 12, we want to write an equation in slope-intercept form of the line that's shown. So slope-intercept form, remember, is y equals mx plus b, where m is your slope and b is your y-intercept. So the first thing I'm going to do on number 7 is to find my m, and then I'm going to find my b, and then I'm going to put that information into my equation. So since I'm given 2 points here, I can count between the points and find my slope. So it's up 1, 2, 3, 4, and over 2. So my slope is 4 over 2, and you always want to simplify if you can. Now, another option for finding slope is by using the slope formula. So I put my y's on top, my y's go on top, 2 and negative 2, and then 3 and 1, and that's going to be 2 plus 2, so that's 4. 3 minus 1 is 2, so that is 2. So it's a different way to find the slope if you'd like to do that. So my b is going to be where the line crosses the y-axis. So in this one, my b is at negative 4. So my b is at negative 4. Okay, so now I'm ready to write my answer. Y is equal to 2x minus 4. Okay, let's take a look at number 8. I need to find my m, I need to find my b. So and then I'll plug it in. So let's find the m first. I'm gonna make my stair step here. I'm gonna count 1, 2, 3 up and 1, 2, 3 over. And it's heading negative. We need to make sure that we note that. So it's negative 3 over 3, which simplifies to negative 1. And my b is where it crosses the y-axis. So what crosses the y-axis at 3? And now I'm ready to write my answer. Y is equal to negative 1x, or I can just write negative x plus 3. You can put the 1 in or not. It doesn't really matter to me. I'm going to do number 11 with you because it's a little bit weird. It's counting by ones on the x's, but it's counting by twos on the y's. So you have to be a little bit careful with this one. I'm going to go ahead and use the slope formula on number 11 since the counting is a little bit weird. My y's go on top, so negative 3 and negative 9, and my x's go on the bottom, 1 and negative 1. So that's going to be negative 3 plus 9, so that's going to be positive 6, and then 1 plus 1 is 2, so this turns into a slope of 3. So my slope is equal to 3. And my y-intercept is where it crosses the y-axis. Now notice it's counting by twos, so this would be negative 2, negative 4, so that means this is going to be negative 6. So my b is negative 6. Okay, so my final answer is y is equal to 3x minus 6. All right, I would like for you to do the remaining problems on your own. Pause the video and turn it back on when you're done. All right, go ahead and check your answers, and if you got something incorrect, see if you can find your mistake. In exercises 13 through 18, it says write a linear function of f with the given values. Whenever they're asking you to write a linear function and they don't specify if it should be y equals mx plus b or the point slope form, which is what we're learning today, always assume that if this is a linear function, we're going to write f of x equals, and then it'll be mx plus b. So always assume that that's what they mean is the slope-intercept form unless it tells you otherwise. Number 13, we have f of negative 3 is equal to negative 1. So that means this point is negative 3 comma negative 1. Then we have f of negative 2 is negative 4. So that means when we plug in negative 2 as our x, we get out 4 as our output. So that's going to be our y. Okay, so this time we're going to do like what we did, what I showed you back on page 103, where you were given 2 points and you have to find the equation. So my step one is to find my slope. So I need to use my slope formula. So negative 1 and 4, and then negative 3 and negative 2. So when I simplify this, I get negative 5 over negative 1, which is positive 5. So if you remember, it does not matter which point you choose. I would always just choose the ones that are it's easiest to plug in. So these numbers, it doesn't really matter too much because they're both about the same as far as difficulty is concerned. I'm going to go ahead and choose the negative 3, negative 1 to plug in to my equation. So we have y minus my y1, which is negative 1, equals my m that I found is 5. And then x minus my x1, I'm using the negative 3, negative 1, so my x is negative 3. All right, so now remember we need to solve for y because we want to get it as a linear function. So this is going to be y plus 1, and then I can distribute my 5, so 5x, and then when I distribute over here, this turns into a plus. So it's going to be 5 times 3, which is 15. Now I'm going to subtract 1 on both sides, and when I do that, I get 5x plus 14. So my answer is actually going to be in the form of a linear function. So f of x is equal to 5x plus 14, and that's going to be my final answer. They don't give you a lot of room on these to work, do they? Okay, let's go ahead and do another example of that. I'm going to do number 14. So we have negative 2 comma 1, and we have 1 comma 7. So my first step is to find my slope. Okay, write my skeleton out. I have to put my y's on top, so that's 1 and 7. And then negative 2 and 1 go on the denominator. So we have negative 6 over negative 3, which is positive 2. Okay, I'm going to go ahead and use the point negative 2 comma 1 to plug in. So we have y minus my y1 is 1 equals my m is 2 that I found, and then x minus my x1, which is negative 2. All right, let's simplify that. I'm going to distribute. So that's going to be y minus 1 equals 2x. This is going to turn into a plus 2 here. So that's going to be plus 4. Now I'm going to subtract 1 on both sides, or add 1, excuse me, add 1 on both sides, and that gives me 5. So my final answer is going to be f of x is equal to 2x plus 5. All right, we're going to skip a few of these just because of time. I'm going to go ahead and have you skip number 16 and number 17. I know we don't do that very often, but I would like for you to try numbers 15 and 18 on your own. So pause the video and then turn it back on and see how you did. Okay, check your answers on numbers 15 and 18. Pause the video, and if you made any mistakes, see if you can find them. In exercises 19 and 20, we want to tell whether the data table can be modeled by a linear equation. So can it or no, and explain. So if it is linear, so it says if possible, write a linear equation that represents y as a function of x. So if it's linear, then you need to write the y equals mx plus b. So let's take a look at number 19. Remember, in order to find out if it's a linear function, we need to see how it behaves. So we have negative 3 up to negative 1 is plus 2. Negative 1 to 0 is plus 1. And then we have a plus 1 again and a plus 2. So now let's see how this behaves. So this is going to be negative 110 to negative 60 is plus 50. And then we have negative 60 to negative 35 is plus 25. And then we have another plus 25. And then we have a plus 50. So it was a little bit worrisome, but remember that this tells us what our slope is, right? So this would be 50 over 2 and 25 over 1, 25 over 1, and 50 over 2. And those are all legitimate. So my slope is going to be either 50 over 2 or 25 over 1, and they're both exactly the same. So if I simplify this, I get 25. Now to write my equation, I need to find out what my y-intercept is. Fortunately, they gave it to us right here. Anytime you have x 0, then that number, in this case negative 35, is going to be your y-intercept. So my answer is going to be y equals 25x minus 35. 25 is my slope, negative 35 is my y-intercept. All right, let's take a look at number 20. See how it behaves. So negative 3 to negative 1, plus 2, and then we have plus 1, and plus 2. So far it behaves the same as number 19. So negative 98 to positive 18 is going to be plus 116. The next one's going to be minus 10, and then we are adding 54. And lastly, we are adding, I'm not even going to bother finding this out because I know that this is not going to end up being the same, right? We don't have, there's no way that these are going to be equal slopes here. So this is nonlinear. And we know that because as x increases, y is increasing by different amounts. Number 21 says, Craig is driving at a constant speed of 60 miles per hour. After driving 3 hours, his odometer reads 265 miles. Write a linear function d that represents the miles driven after 8 hours. What does the odometer read after 7 hours of continuous driving? So the first thing I want to notice is that I have my slope. It's right here. Constant speed of 60 miles per hour. So my slope is 60. The second thing I notice is that I have, after driving 3 hours, the odometer reads 265. So that means that my point is 3, 265. So what I could do is I could plug my slope and my point into the point slope form and then solve for y. But I can kind of think about this a little different way. After 3 hours, he's driven 180 miles because he drives 60 miles per hour. So if we subtract 180 from here, that will tell us what his starting point was. So 265 minus 180 is 85. So that means that he started at 85. This is the y-intercept. So that means that I know my slope and my y-intercept, and so that's 85. So we need to write a linear function. So we want to write d of h. So this is the distance of h hours equals my slope, so 60, and then h plus 85. So that's the first part of my answer. My second part of my answer is asking, uh, what does the odometer read after 7 hours of continuous driving? So what we need to do is substitute in 7. So d of 7 and find out what that is, and then we'll know what our answer is for that second part. So if we plug in 7, it'll be 60 multiplied by 7 plus 85. And using my calculator to help me, I see that that is 505. So that means after 7 hours of continuous driving, Craig has driven 505 miles. Okay, that's it. I know this was a long one. I'm sorry, guys, but sometimes that happens. Thanks for listening.